Hi, this is GOMATHY doing my final year M.Tech project in SRM University. My topic is automated segmentation and classification of thyroid gland using ultrasound modality. My project guide Dr. U. Snekhalatha. The main aim of the project is to segment the thyroid region and to classify its disorders by using feed-forward backpropagation neural network. Objectives: here to segment the thyroid region using dual thresholding method and to estimate the area and volume of the thyroid gland from segmented image. Then to extract various features of the thyroid gland by using gray thresholding method, and finally to classify its disorder whether hypothyroid or hyperthyroid or a normal case by using feed-forward backpropagation neural network. Methodologies: initially data collection followed by segmentation by dual thresholding method. Under segmentation we have pre-processing step by using principal component analysis, morphological process. From segmented image we can estimate area and volume, and we can interpret its value according to the age groups, and feature extraction by using gray thresholding method. Under feature extraction we have multi-wavelet transform, texture features like energy, entropy, contrast, correlation, homogeneity, skewness and kurtosis. Finally classification by feed-forward backpropagation neural network. Data collection: here there are 60 images of thyroid ultrasound is used, from which 30 is a normal case and 30 is an abnormal case, which includes hypothyroidism and hyperthyroidism. The mean age of the patient is about 25.6. Inclusion criteria of the image: it includes various thyroid disorders, and excluded criteria in the sense operative cases, throat cancer, throat inflammation, infection, any cystic problems are not included. This is the collected test reports from the reputed hospital. Here we have total free T3, total free T4 and TSH test reports of the patient along with the ultrasound image. This is the block diagram of this system. Here ultrasound is an input image. In segmentation we have pre-processing step by using principal component analysis followed by morphological process and then masking, where segmentation output is given as an input to the feature extraction that further processed multi-wavelet transform, GLCM and texture feature extraction. This can be given to the classifier, where feed-forward backpropagation neural network is act as a classifier that process the image and results output whether the given image is a normal or abnormal one. In case of abnormal, it display whether it is a hypothyroidism or hyperthyroidism. From segmented image we can also calculate area and volume values. This is the input image collected from the hospital. This image taken from the ultrasonogram equipment, where probe is placed on the throat by applying gel, and receiver receives an image which is displayed on the system. This image is further processed for diagnostic purpose. This is the pre-processed image. Here principal component analysis is used as a pre-processing step. This will convert the multi-band to the single band, where PCA is used to reduce the large dimensionality of the data and multispectral band reduction. Hence it is useful for discriminating the patterns of different signals with limited features. So the band reduction is used to explain the majority of its variability compared to multi-band features. This is the segmented output. Here we have some unwanted structuring elements. So we does not get perfect thyroid gland. In order to reduce such unwanted structuring elements, we going for morphological process, where this is the morphological output. This image defines a perfect thyroid gland shape. Morphological operations are applied on the segmented image for smoothing the detected part. So it processes the image based on its shape and performs it by using its structuring elements, where dilation and erosion were performed in the morphological process in order to eliminate the unwanted structuring elements and to add the structuring elements wherever needed. Masking. Masking is nothing. It shows the region of thyroid gland which is segmented from the input image. This is done by KL transform. This tabulation shows the volume and area estimation, where the thyroid volume and area detects the segmented thyroid gland with its respective units like mm square and mm cube. This can be used to check the variability in size among different age groups. Feature extracted values were shown here. Feature values for low subband in the second tabulation and low high subband in the first tabulation. This is a continuation of the tabulation. Here, Haar wavelet transforms were used. The Haar-based transform decomposes the image into different subbands, where it splits the components into numerous frequency bands, which is called subbands. We have 4 subbands: low-low, low-high, high-low and high-high subbands, where high-frequency subbands contains the edge information of the input and low-low subbands contains the clear information about the image. GLCM. The co-occurrence matrix is performed by calculating how often a pixel with the intensity of gray level value I occurs in a specific spatial relationship to a pixel with the value j. So the number of gray levels in the image will determine the size of the CCM, that is co-occurrence matrix. Here they have shown energy, contrast, correlation, homogeneity and entropy. These are the Harlick features extracted in feature extraction stage. Energy is nothing but it is the measure of homogeneous of the image. So it can be calculated from the normalized CCM, where entropy gives a measure of complexity of the image. Contrast measures the local variation and texture of shadow depth, where correlation coefficient will measure the joint probability occurrence of the specified pixel pairs. Homogeneity will measure the closeness of the distribution of elements in GLCM. This is the neural network block. This is the input and multi-layered hidden layers were used, and this is the output. Here we can show the performance graph, training state and its regression. This is the exact image how the neural network getting trained. Actually, supervised learning based classifier was used for image classification. Feed-forward backpropagation neural network model is used here to act as a classifier for neural activation function. For classification, we need testing and training. Finally, the test image features are stimulating with trained network to make decision of thyroid stage like abnormal or a normal one. This image will show it clearly. Here, hypo stage. So thus that the given input image is a hypothyroidism case. Actually, according to neural network, each unit taken as input applied into a non-linear function to it and then passes the output to the next layer. So generally the networks are defined to be a feed forward. A unit feeds its output to all the units on the next layer. Hence, the process is recorded at one time, learned by comparing the classification of the record with the known actual classification of the record. The specificity is about 85%, sensitivity is about 85%, specificity is about 100 and accuracy is 90%. This shows that this system is so efficient. Advantage of this system, it can segment the thyroid region from the image accurately and automatically. It is useful for classify the image into normal, hypothyroid and hyperthyroid. Thyroid disorders will be detected in an early stage. This system is time saving and it will minimize the errors caused due to the manual calculations. Thank you.